First, you've been referred to as the father of the moon missions. How do you feel about that title?
No, I don't know how much I am. These only people are in the fond of love that I'm talking about. But it basically, I think it's really a matter of pride to be a part of the Indian first mission to the moon. Okay, being a project director of the mission, definitely a part of that mission. I was really feeling happy, no doubt on that, and that paved the way for the India's aspiration to go beyond into the space. Okay, even for the mission like Mars, I think that is a efficiency.
And you quite rightly say it was the very first mission, and so far the only mission to the moon. And it was launched in 2008, quite some time ago. And the mission was, in all accounts, very successful in terms of science, the international collaboration, and it was a great boost to the nation and a lot of individuals, students involved in space as well. What do you think, one single aspect of the success of Chandrayaan-1 do you think is the most important?
No, you look at overall the success of the mission is both scientifically as well as overall what is concerned. Discovery of water molecules on the surface of the moon is definitely a great thing. Overall.
And it means so much for future generations.
Exactly.
The Chandrayaan was in 2008. Chandrayaan-2, what's the status of that mission now?
Chandrayaan, after Chandrayaan-1, Chandrayaan-2 went with that basically a logical extension to have a lander and have a rover on the moon. That's the idea in which. And in this part, Chandrayaan-1, we had a collaboration with the various international partners. And Chandrayaan-2, the partner, Russia was not a part of Chandrayaan-1. Chandrayaan-2 basically came with the Indo-Russian collaboration. That is the mode we arrived at. But unfortunately, due to the problems within the Russian things like that, it is getting delayed because they want to reconfigure the mission slightly different way and the schedule was not matching. So it calls for a mid-course correction for the overall mission is concerned. So now probably we are looking to the reconfiguration slightly differently, wherein it's an all-Indian mission, wherein the launch by us, orbiter by us, rover lander by us, like that. So it's slightly reconfigured. So accordingly, maybe it will take another 2 years redefinition. Because of redefinition, it is slightly getting delayed.
One thing on Chandrayaan-1, as you said, it was the first mission to the moon. It was the first mission for ISRO beyond Earth orbit. What challenges did you have to overcome for that particular aspect of the mission? It was so far away relative to the previous missions.
Because all along our missions are either remote sensing or communication is Earth-oriented mission. The first time going away from the basically capturing around the moon. Basically, lunar capture itself is a challenging thing. If you really look at the previous, we have before Chandrayaan, if I recall, nearly 16 missions have gone to the moon at 16 missions. But initial attempts were not that much successful. Considering that we are making the first attempt, we have to make a success. That was a real thing. And over and above that, even within our missions, also remote sensing or communication, we used to carry only 1 or 2 instruments. But this time we carried a fairly good number of instruments. Equal contribution, both national as well as international laboratories. So this made really a challenge to bringing all the instruments together, making it work, integrate, taking it to within the stipulated time and money. So there is a real challenge. I think that we have made it fairly good.
And I think it won some awards because of that international collaboration as well as the scientific success. One of the things that's keeping you very busy these days is the Indian mission to Mars, the Mars orbiter mission. What's the state of play with it right now?
I think presently the mission is doing well. It's cruising towards Mars. Basically, this is now in the heliocentric phase around the sun. It is moving, but as of now, everything is going normal, and we expect in September we will be able to capture the Martian orbit as planned. I think otherwise everything is going well. And in between, once in a while, we are switching on and calibrating the instruments also. And as on today, yesterday we had a review of all the instruments, how it doing well, en route to the Mars. And I think the initial signatures indicate all the instruments, 5 instruments are doing well.
The images that was published from the Mars orbiter mission whilst it was still in Earth orbit was published. Beautiful picture of the Earth. You didn't take a picture of Mars orbiter mission didn't take a picture of the Earth Moon system as it was going away from the Earth. Did it not do that?
I think we are not better at because that opportunity didn't come. I think. Okay. Then now what is happening is now when it is going in the cruising phase when we are going, we would like to give minimum disturbance to the spacecraft because we want to preserve the fuel as possible. So any small disturbances accordingly have to account for the overall orbit is concerned. So the plan is to keep it as it is and keep moving towards that and
very sensible.
Very sensible.
Yes. Whilst it was still in Earth orbit, it was in Earth orbit and picked up gravity assist by 6 orbits. On the 4th orbit, there was a slight problem and it didn't pick up the energy, the speed which it required. What was the cause behind that?
Yeah, if you recall the thing, we have already told it also very clearly. The basic message is we want to energize all the redundant system also during the same time, because this is how when we are near the Mars in orbit, the time delay is fairly big. Real time we cannot operate, we cannot react. So ensure all the both main redundant systems work together and make sure that similar thing happening there. But unfortunately, the first time we are doing such an operation, any one of our missions there. When we energize that, especially the 2 coils, which has to energize the valves of the 440 Newton engine, and there was some issue of the polarities, which it has, and unfortunately there was not tested the way in which it was tested, but separately. The one at a time valve was tested, but both were energizing simultaneously, each was opposing the other activity. Because of that, effectively the valve didn't open. Originally, what you have done is we energize both the coils. In case one of the coil not working, other coil will take. That is the idea. Now the plan is something like this. You energize coil 1. In case it is not coming, within a few milliseconds you will be able to understand because it is not in our test. Then switch off that and bring the other one. So onboard computer has been accordingly modified, software has been accordingly modified, so that one will watching for happening, how it is effective happening there. Not happening, you bring the other one. So that without ground intervention, that function can take place.
One last question on the Mars orbiter mission. When it was launched, on the day it was launched, the liquid apogee motor you mentioned was fired, and it's been fired several times since then. The last time it has to fire is when it arrives at Mars on the 24th of September. That'll be a 10-month gap between the first firing of the liquid engine motor and the then firing. And although it's a very reliable motor, it's never had that kind of time gap between the first and final firing, has it?
Yeah, in flight, yes, we didn't have such a requirement was not there previous missions. Chandrayaan is hardly a week or 2 later. But whereas here we have to fire nearly 10 months later. But however, what we have done is we have made a fairly good number of 3-4 engines in the ground. We underwent the test. We have underwent the test because once we know this is the only thing we identified which is the major deviation from the other missions. This is the only thing. So we have identified 2-3 similar engines in the ground. We have a good confidence systems will work.
So the testing you've done here on the ground. You mentioned in Chandrayaan 1 there was a lot of international collaboration in terms of the science package. These are all Indian ISRO instruments, but do you have any collaboration in terms of communication and relay with NASA or ESA as part of the
overall mission point of view, yes, we had the collaboration with the Deep Space Network of NASA stations, all the 3 from Goldstone, Madrid and Canberra is a part of our network to track the system, to update the orbits point of view. Yes, we do use that in this mission also.
And I suppose it works both ways. There are times when NASA or European Space Agency needs help, and I know India has an extensive and growing deep space network as well. So it works both ways.
I think many of the low Earth missions and as well the communication missions, our ground stations already part of the other international partners. And we do, I think, some sort of access already is on. Probably in the years to come, our Bangalore DS and also may be part of the international other partners planetary mission. I think it's not, days are not very far.
Touch on, I know you do so much in many other areas, but just to touch on the science missions, I know you're involved in some respects dealing with the upcoming science missions, the AstroSat and the DITA. Can you tell us a little bit about what those two missions are about?
AstroSat is basically a full-fledged astronomy mission, wherein the visible to UV, hot X-ray, the wider spectrum, 5 instruments, the full wavelength. It has the instruments to look at the cosmic system and to understand that. That point of view, that is the instrument is already in the final stage of integration. Hopefully, the satellite will be ready by year end or early next year. So that's the the satellite is already in the very final stages of integration.
I see.
And then we have the mission Aditya, where solar chronography to study is concerned. And that mission also probably another 3-4 years from now. It is basically conceptual stage now. And we are thinking of putting in the alone Lagrangian point and try to see a continuous visibility of the sun. And that is for the solar study. That's going up. This is also part of the science upcoming missions.
And it's not, I think many people around the world weren't aware of the Indian space program until the Mars mission. And I know that although these are Aditya and AstroSat are pure science missions, there's a tradition within ISRO. These aren't the first science missions. You've done many before it in the past, haven't you?
No, that way you look at here, even our first mission itself is some sort of thing. Aryabhat is X-ray mission by Professor Rao. So we started that science mission, but afterwards it's become more and more of a societal needs once we build up the system. So that way you look at here, the science missions are playing only a small fraction of the overall effect. Otherwise, predominantly the remote sensing or communication missions meant for societal applications.
Vikram Sarabhai's view of space objectives for India was to help the common man. Do you think it's fulfilling that role?
It's. I think if you look at here, India is the one country where the last 2 industrial revolutions it lost using the benefits. So now we have to go leapfrog the overall system to catch up the world. So that way we feel the space is the one vantage point which will help the people to help it. Either in terms of India is where the number of school rooms, you look at classrooms are much more than any part of the world. And even the medical healthcare system also calls for a fairly good number of people to attend to them. And this, for example, these are all things where, for example, tele-education, where the quality teacher can connect to the various nooks and corners of the villages. It's possible. I think it's happening there. And we have the telemedicine, it's happening there. And India is a country, vast country, where the human resource is more, natural resources also has its own limitation. So natural resources need to be managed properly. We feel the Indian remote sensing satellite is a backbone of the national resource management. Therefore, because many things are happening to using the satellites. So that way, today common man, either in terms of education or healthcare or natural resources or the crop monitoring or even the fisherman to fish catch. I think very many things are space is connecting the common man in much better way.
Dr. Annudari, I know you, as well as being a dedicated scientist and engineer here, you take your time to explain and share what you do and with everybody, including me. Thank you very much.
Thank you.